Hello everyone, this is Vishnu. I am from NID Puducherry, first year Computer Science and Engineering Department. Today I am going to discuss about exploring the world of logic gates. Welcome to Exploration of Logic Gates, the building blocks of digital circuits. We will delve into their fundamental operation, understand their behavior and explore their application in modern world. Applications of logic gates. We use logic gates in computers and microprocessors. Okay. Then we go with fundamentals of digital logic. There are three ways: binary representation, Boolean algebra, and truth tables. In the binary, firstly we go with binary representation. In binary representation, digital circuits operate on binary logic using only zeros and ones to represent state of on and off. Boolean algebra provides a mathematical framework for describing their behavior of logic gates. Finally, the truth tables. Truth tables are used to visualize and depict the output of a logic gate for all possible combinations of inputs. Okay, then we go with gates. There are three gates, normal gates we use usually: AND gate, OR gate, and NOT gate. Now we're going to discuss about AND gate. In AND gate, in three steps. First one is output is truly only when all inputs are true. Listen once more. Output is truly true only when all inputs are true. The AND gate outputs 1 only if all the inputs are 1. Otherwise, it will output as 0. And second one, represent the logic and operation. The AND gate implement the logic and operation, often represented by the symbol ampersand. And third thing, example: switch 1 and switch 2 must be on for the light to turn on. Imagine two switches controlling a light. The light turns on only when both switches are in the on position. Okay. Now we go with OR gate. OR gate, first output is true if at least one input is true. Listen once more. Output is true if at least one input is true. By the way, the OR gate output say 1 if at least one of its input is 1. It output as a 0 when all inputs are 0. And second thing, represent logical OR operation. The OR gate implements the logic OR operation, often represented by the symbol 1. Example: if you press button 1 or button 2, the alarm will sound. Consider an alarm system with two buttons. The alarm sounds if either button is pressed. Okay. Then we go to next gate. And finally, we came at the NOT gate. This is the NOT gate, the last natural gate. A normal gate we use a lot. The NOT gate inverts the input. Its function is inverts the input signal. The NOT gate is simple inverter. The output opposites of its input. If A1 is input, then 0 is the output. If 0 is the input, then 1 is the output. And represent logical NOT operation. The NOT gate implements the logical NOT operation, often represented by the symbol not equal. Okay. And last example: a switch that turns the light off when it's on. Imagine a switch that controls a light. Pressing the switch when the light is on is it off, and vice versa. Okay. Then we go to discuss about universal gates. There are two types of universal gates: NAND gate and NOR gate. Then firstly we are going to discuss about NAND gate. In NAND gate there are three steps. As like firstly we discussed about that AND gate like that. And firstly, output 0 only when all inputs are 1. The NAND gate outputs a 0 only when all inputs are 1. Otherwise its output a 1. Second one, inverts the output of an AND gate. It essentially behaves like an AND gate followed by a NOT gate. You got the point? It essentially behaves like a AND gate and followed by a NOT gate. Example: the door will unlock only when the key is not inserted. Listen once more the example: the door will unlock only when the key is not inserted. Consider a door lock. The door remains locked unless the key is not inserted. Okay, now we're going to discuss about the second universal gate, NOR gate. NOR gate output 1 only when all inputs are 0. The NOR gate output a 1 only when all inputs are 0, otherwise its output is 0. And second thing, invert the output of an OR gate. It acts as an OR gate followed by a NOT gate. Let me going to discuss about an example. The alarm will sound if neither button is pressed. Consider all alarm systems with two buttons. The alarm sounds only if neither button is pressed. Then let me go and discuss about the XOR gate. In XOR gate, output 1 when inputs differ. The XOR gate outputs a 1 if the inputs are different. One is 0, another is 1. If the output a 0, if the inputs are the same. And represent the exclusive OR. The XOR implements the exclusive OR operation, often represented by the symbol. Example. In the example, a light turns on when only one switch is on. Only one switch is on. Imagine two switches controlling a light. The light on only when one switch is on, another one is off. Then thank you. This is Vishnu from IIT Puducherry, first year Computer Science Engineering Department.